Hi students, today we are going to discuss on the topic called electromagnetic flow meter. So in the previous videos we had a discussion on so many different types of flow meters like Orifice, Venturi. Then we had a discussion on hardware anemometer. Then we had a discussion on turbine meter is, but today the topic is electromagnetic flow meter. So while you are comparing all the flow meter, this one is very uniqueness on several factors. The advantage, which is nothing but it causes no obstruction to the flow path. And moreover, in industrial, most of the areas they are using electromagnetic flow meters only, because of it gives a linear output in the form of voltage. Linear output, which is nothing but there will be a proportionality change. So that is what linear output, and the output will not affected by any changes in the pressure or temperature or viscosity of the fluid. And moreover, even using this particular meter, reverse flow also can able to measure. The flow velocity is very low, as low it's like 10 power minus 6 meter per second can also measure. The electromagnetic flow meters, the companies are Rosemount and Immersion. So these are the producer of electromagnetic flow meter. And the main application of this electromagnetic flow meter is it is mainly used for slurries, sludges and electrically conducting fluid. So whenever the liquid is contained, there is a conduction principle, then the people used to go for electromagnetic flow meter. Your electromagnetic flow meter is working on the principle of Faraday's law. You all know Faraday's law. The Faraday's law, which is nothing but whenever a conductor is placed in a magnetic field, an EMF get induced across the conductor. And when you are looking at the electromagnetic flow meter, it is like in the top surface there will be a transmitter and the receiver as well as sensor. So that is the reason electromagnetic flow meter is also called it as a transducer. So this is how the construction part of electromagnetic flow meter it looks. So here this is your flow path. So velocity of the fluid flow, and there are two coils. And using these two coils we can able to capture the voltage and the particular thing which is consists of a magnetic field coil. So this is called as a flow tube and the liquid product. So here there is a generating voltage is E and velocity is V, and the magnetic field created through the coil which is B and the diameter of the particular tube. So here the induced voltage, average liquid velocity, magnetic field and the distance between the electrodes. That is, there are two electrodes, so the distance also calculated. So whatever the voltage generated as an output is directly proportional to the induced voltage, directly proportional to the average liquid velocity, magnetic field and the distance between the electrodes. So electromagnetic flow meter are suitable for measurement of velocity of conducting and weakly conducting liquid. It works on the principle of electromagnetic induction, that is also called Faraday's law. When a conductor moves along a magnetic field, when it perpendicular to the direction, a voltage induced perpendicular to the direction of the movement as also the magnetic field. And here which one is acting like a conductor? That is your flowing liquid. The flowing liquid, it act like a conductor. An external magnetic field which is applied perpendicular to the direction of the flow. There are two electrodes on the pipe, that is the above portion and the down portion. When it is get strike on the pipeline, then there will be an voltage induced. So the induced voltage, which is E0, that is equal to BLV. So B is your magnetic field, L is length of conductor and V, which is nothing but velocity of the liquid. That is how the voltage is measured using this particular electromagnetic flow meter. So the above expression will give a complete relationship between the voltage induced and the velocity. And the magnetic field applied, it is not an DC, if the liquid medium is water or any other polarizable liquid. That is because the voltage induced also DC and a small amount of DC current will flow if a measuring circuit is connected to the terminal. So the small DC current, what it will do, it will cause an electrolysis. So oxygen and the hydrogen bubbles will be formed and they will stick to the electrode surface for few times. So that will provide an insulating layer on the electrode surface that will disrupt the voltage generation process. As a result, the magnetic field applied for this case is AC or pulsed DC excitation. Then only it can be used for measuring the liquid having moderate conductivity. So as a result, it is not suitable for gases or liquid hydrocarbon, and the accuracy is about plus or minus 1%. And I would like to show you the video also. You can just look at the diagram, what the animation thing. This is how the pipeline it looks. Here you can just see. This is the pipeline, and the pipeline, the upper and the lower portion, you are having a field magnetic coil, and which was mounted within pole shoe. Using that, which was mounted on the upper and the down portion, and either side, these two, I think you can able to see, and these two coils are used to capturing the voltage generated through this particular magnetic coil. You can just look at the diagram. There is for capturing the voltage, there are two pickup coil we have. These two coils we have. And for this particular thing, when the liquid get flow, that is the flow is, if there is no flow, then it will not indicate that pink color and the blue color one. If there is a flow of liquid, then automatically it will indicate. So if there is a flow across the field lines, that is your magnetic coil, the magnetic field is generated. Due to that, there will be an EMF induced along those two sides. So what is happening? The positive and the negative one get separated. So the positive going in one side and the negative ions going in another side. Due to that, there will be an induced voltage. That voltage will be generated across those 2 points. So you can just able to look at the diagram of this. Here the flow of liquid, due to magnetic field line, it is getting oriented towards the positive and the negative thing. So this is how the electromagnetic flow meter is working. This is the inner part of the electromagnetic flow meter. So whatever the horizontal lines you can able to see from the top to bottom, that is green to red color, these lines are called as a magnetic field lines, and the red dots and the blue dots, they are called as an ion particle. So due to the magnetic field, how the liquid particles are getting separated. This is how the electromagnetic flow meter working based on Faraday's law, that is E, which is equal to KB dV. K, which is nothing but proportionality constant, and B, which is nothing but magnetic field strength. D is distance between electrodes. V is velocity of process liquid. So this is how the electromagnetic flow meter looks. So when you are looking at the diagram, this is actually, the company is Rosemount. or else the electromagnetic flow meter, they are going for immersion. So the above portion you can able to see the manufacturer details. Along with that you can able to calculate the values of velocity that will be directly indicated through this particular meter component. So I think you would have understand how the electromagnetic flow meter is working. Not only that, the diagram, expression, construction, and how it is working when it is used in the industry point of view. Thank you.